is video 2 covering lecture content from Wednesday and Friday. And so this picks up right where video 1 left off, and we're talking about information processing theory. And in this video, we're going to go in depth in talking about sensory memory and the process of attention. And in the final video, we'll deal with perception. So let's start with talking about sensory memory. As I said before, whenever we're talking about IP theory, we're talking about 3 core memory systems: sensory memory, working memory, and long-term memory. And so in addition to being able to compare the function of each of these memory systems, so what they do in terms of processing information or storing information, the way we can think about the potentiality of these memory systems is by examining their capacity and duration. And when I say capacity, I'm talking about how much information they can hold. And when I say duration, I'm talking about how long they can hold information for. And really, these two components, kind of how much information they can hold and how long they can store the information, are what define each of these memory systems. And so you're going to see this chart a lot, but we're going to start here with sensory memory. And so what I'm going to ask you to do is think about the capacity and the duration of sensory memory. So just in terms of quite a lot, so very, very large or very, very small, think about what is the capacity of sensory memory, how much information it can hold, and what is the duration of sensory memory, how long it can hold information for. And as you think about those, I'm just going to talk to you a little bit about what is included in your sensory memory. So your sensory memory takes in raw, unprocessed input from the environment. It's just where the information comes in. And I like to think of sensory memory in terms of the 5 senses. So right now you're experiencing things through your eyes, through what you hear, through touch, through smell. And so right now in this moment, you hear me talking, you may hear one of your neighbors talking, you may hear the din of the air conditioner in the background, you may hear someone rustling a piece of paper, you may hear what's going on outside if people are passing by the room. At the same time, you're seeing the screen as this video is being projected. You're seeing your laptop or your notebook in front of you. You're seeing people in your peripheral vision. You're seeing your neighbor who's walking in front of you. You're feeling the pen or the keys in your fingers, the pressure of the clothes on your body, the floor underneath your feet, the chair that you're sitting in, and you are perceiving, maybe you smell your neighbor's shampoo, and you're perceiving all of these sensations all at the same time. And so really every neurological ending that we have in our bodies is able to capture sensory information. And so with that in mind, think about the capacity of sensory memory, how many things you can sense in any given moment. And I'd also like you to think about the duration of sensory memory. And so what I'm going to do on the next slide is I'm just going to show you a set of letters, and I'm going to ask you to remember them. Okay, write down anything you remember. Let's see that again. And so in case you're wondering, that slide was timed to show you those letters for less than a second. So 0.8 seconds is how I timed it. And this comes from actually a classic study by a researcher named Sperling. And I'll just show you the link. I have it in the slides here too. If you're interested in the study, I would really recommend that you go and kind of check it out. I'm not doing it in class because it's a rather long protocol. But it was basically a study that flashed letters, just like I showed you guys. Let me show you this. It was basically a study that flashed letters just like I showed you guys, and based on the letters that participants were able to remember, you were able to think about the duration of sensory memory. So let me show you a couple of examples here. It'll go to the next trial in a second. Okay, how many letters did you guys see? And so what's interesting about this is that you actually saw all of the letters. but you didn't really remember them. You weren't able to register them precisely. And so that gives us some information about the capacity as well as the duration of sensory memory. And so when we're talking about sensory memory, I'll show you this again. Oh, go forward. So you saw all of those letters, you took all of that information in, but you only hold that information very briefly, which is why it's hard for you to reconstruct the letters that you saw. And so that gets us to the capacity and duration of sensory memory. When we're talking about the capacity of sensory memory, it's very, very large. Like I mentioned, every neural ending in your body is able to perceive sensation. And so it can hold a ton of information. And I talked about sensory memory in terms of the five senses, but really the two types of sensory memory that we're going to focus on are iconic and echoic, because those are the two that have been studied the most. They're primarily how we receive our information, particularly in terms of learning. And so you can probably guess what I mean by iconic memory, but think of an icon, so kind of a picture. An iconic memory is your visual information, is your sensing of visual information. It's any pictures, images, graphics that you see. Anything you see goes into your iconic sensory memory. So when I showed you the letters on the previous slide, I was assessing your iconic sensory memory. The second type of sensory memory that we're going to be talking about is echoic. And again, if you think about the word echo, it gives you a clue about what kind of sense I'm talking about here. And that's your memory for auditory information. That's any sounds that you hear. Of course, it's primarily linguistic. So as you're hearing me talk, that's your echoic memory coming into play. And so these are the two types of sensory memory that we're going to be talking about. Notice that these are two different memory systems. And what that means is we perceive iconic information differently than we perceive echoic information. So I see images, I hear sounds. The content itself is different, so it's either visual or auditory content. And as we'll see, how long you can hold information for, the duration of both of these memory systems is a little bit different. And so on the previous slide, you saw the duration of iconic memory. We can't hold the images in our minds for very long if we don't process them. And so generally the capacity of sensory memory, the duration of sensory memory is very, very brief. So we can take in a lot of information at the same time, but we don't hold on to it. We sense it, and then if we don't do anything more with that information, if we don't process it in working memory, it's gone. A test I like to do is if you pinch yourself, how long do you feel that sensation for? Not very long at all. The duration is very brief. When we're talking about visual information or iconic memory, it's less than a second. So on the previous slide, you saw the letters, they were timed to appear for less than a second. And so I'll just add that you'll see different estimates for how long the duration of these different memory systems are. So as we become more and more precise in measuring these things, as we develop new experimental methods, some people will say 200 to 400 milliseconds, which is a lot less than 1 second. Some people will say, well, it's just less than a second. And the truth is that it's so quick that it's very hard to assess. And in terms of processing, unless you're someone who's very interested in perception, so how quickly you can detect different stimuli, just thinking about it as very, very brief will be just fine for our purpose. So we can only detect visual information very, very briefly for less than a second, unless additional processing happens. Auditory information is a little bit longer, and the typical estimate you'll hear is 2 to 4 seconds. Some people will say 3 to 4, some people will say 1 to 4. And that's the idea of how long you remember the last thing that I said. So for how long you can repeat exactly the last words that I said. And that's probably, you can repeat the last words that I said, and that probably has to do with the duration of sensory memory. It probably lasts about 2 to 4 seconds. And so an interesting thing about the longer duration of echoic memory, so look, it's almost twice the capacity of iconic memory, is that that's what enables us to be able to communicate through language, right? That's what enables us to communicate through human speech. Because in order to understand what I'm saying, you have to be able to link the words that I'm saying at the beginning of my sentence with the words that I'm saying at the end. You have to store kind of the immediately preceding words in your sensory memory. And so that's why the capacity of echoic memory is a little bit larger, because it actually facilitates communication. So very generally, when we're talking about sensory memory, we're talking about being able to take in a ton of sensations at the same time, but we don't remember them for very long at all. And the other example that I like to use is think about yourself at Starbucks or kind of a very busy place like a mall. So you're taking tons of information in, right? People are walking by, you hear all kinds of sounds, the escalator, the dings of cash registers, music playing, the conversations going on around you, the rustling of bags, someone dropping something, someone picking it up, and you perceive all of that at the same time. But you're not really processing it. It's almost unconscious. And the reason that it feels unconscious is because you don't hold on to that information for very long at all. Kind of the minute you perceive it, you dump it. And so the sensory memory is very, very brief in terms of the information it can hold. But some of the information that we take in, we hold on to for longer. And in fact, we process it from working memory. And so once information just enters into sensory memory, again, that's raw, unprocessed data. There's two processes that move information from sensory memory to working memory. And I'm going to talk about the first of those right now. Of course, that's attention. And so we use attention colloquially all the time. So we say things like, I need you to pay attention to me, or I need your attention, give me your attention up here. We say attention all the time. And so I can ask you to turn to your neighbor and define attention for them right now. But I'll just tell you that when we say attention, we mean the directing of cognitive resources. We mean kind of focusing your attention or your cognitive resources on a particular stimuli. And so typically when we talk about attention, we focus on one stimuli to the exclusion of others. So when I say focus your attention up here, what I'm also saying is focus your attention up here and don't focus your attention on anything else around you. Of course, as you can probably imagine, attention is limited in capacity and duration. And it's highly distractible, and we'll talk about all of those characteristics, but I'm not sure if I wrote it on this slide. But the other thing that I wanted to mention about attention is that we're always focusing on an external stimulus. So when we talk about attention, we tend to say kind of focus on something in the environment, direct your mental resources to that stimuli outside of yourself. And so really crudely, when we talk about attention for now, we're going to be talking about the directing of cognitive resources. And there's two types of attention that we're going to be talking about: automatic attention and purposeful, or what's called selective attention. And I'll talk about each of these separately, and then we're going to kind of compare and contrast them more systematically. So automatic attention is when something external gets our attention. So for example, if I clap, you guys would look up here, right? That would be your automatic attention. Or if I flick the lights, you would look up, and that would get your mental focus. And again, it's directed towards something external, so you would be looking up at me if I were here, or you would be looking in the corner to whoever flicked the lights. But it's also externally triggered, so you didn't do anything. It automatically happened. So the minute I clap, you guys look up here. It's externally triggered. But sometimes you can choose to pay attention to something, and that's called purposeful or selective attention. So for example, when you're reading, you're paying attention to something external, but it's an internal decision to pay attention. So I am choosing to pay attention to the book in front of me. Or right now, as you're listening to the lecture content, you are choosing to pay attention to this stimulus. And so very broadly, when we talk about automatic attention, we're talking about attention that's externally triggered. So something like clapping or saying, look up here, or if I shouted or something, whereas selective attention is the internal directing of attention to an external stimulus. That's you deciding to pay attention. And so I'm going to show you a demonstration of selective attention because that tends to be kind of the more interesting one for us. And then we'll go to talk about the difference between automatic and selective attention. So I'm going to show you this video right here. And again, this comes from a classic psychology study. So it's kind of fun to see this. This video again in class. I encourage them to do so. The link is right here. But what did you notice about your process of paying attention to this video? And I'm just going to take 30 seconds and let you really talk to your neighbor about what did you see about yourself as you were paying attention to the number of players passing the ball. Okay, so hopefully these are some of the things that you talked about. So first, in terms of selective attention, we focus on a stimulus, right? So you were really able to keep track of the players in white passing the ball back and forth. It was also controllable, so you yourself decided to focus on the players passing the ball. You controlled your attention. You were able to exclude irrelevant stimuli. So hopefully the big thing you picked up on is if you saw the experiment before, maybe you noticed the gorilla, maybe you didn't, but you probably missed the curtain, you probably missed the player in black leaving. But that's fine, right? That's actually adaptive because your assignment wasn't to care about anything else. You were able to focus on, your assignment was just to focus on the players in white passing the ball. And so you were able to exclude irrelevant stimuli, which is really useful if you think about it. So for example, if you're studying and your cat is jumping up on the table, down off the table, and your roommate is watching TV, eating popcorn, that's not great for your studying, but it allows you to exclude certain irrelevant stimuli. If you need to, you're able to exclude all of those things that are going on around you. Going back to our shopping mall example, if you're walking around in a really busy shopping mall, you're able to kind of tune everything else out and focus on the conversation that you're having with your friend. So it allows you to discriminate between the volume of information that's entering into our sensory register and just focus on some of that. We'll talk about the distractibility by automatic attention, so I'm going to leave that one off for now. But at the same time, here are some other things you probably noticed as you were trying to pay attention to the players in white. So first, paying attention is always effortful. It always requires cognitive effort or the expenditure of cognitive resources. And so another way to say that is paying attention isn't easy. You probably had to really focus. And linking that back to what we talked about in terms of the benefits is that when the more irrelevant stimuli you have to exclude, the more different kinds of things that are going on, the more effortful it becomes to focus on the stimuli you care about. So for example, the exercise would have been much easier if there weren't any black players passing balls, if you only had to count the white players. Likewise, if I added another color, so players in blue were also passing the ball, that would have made paying attention to the one stimulus you cared about, the players in white passing the ball, that much more effortful. So it always requires effort. And so that's also, we'll talk about the implications of this from a classroom perspective, but that's one of the things you want to think about when you're thinking about your own students. It takes effort to pay attention. It may be difficult to sustain. So because it's an effortful process, it's hard to pay attention for a really long time. And so think about kind of really honestly with yourself. How long can you read something pretty dense? So not watch a movie because that's a pretty easy stimulus. But how about reading your ed psych textbook? How long can you really read without stopping, kind of really thinking about it before you look up and look at something else or check your phone or make a quick joke to your neighbor? So sustaining attention takes a lot of effort. And so there's kind of a pretty broad span in how long people can maintain attention for. And the way that we assess attention really varies. So kind of reading may be more taxing than another form of attention. So just paying attention to a visual stimulus. That being said, kind of adults' attention capacity tends to hover in the 20 to 30-minute range of performing intensive cognitive tasks without taking a break. And it tends to be much younger for younger students. So the rule of thumb that teachers tend to get is before students are fully developed, so before kind of late high school, you can think about their attention capacity as their age plus 1 or age plus 2. So if I have a 5-year-old, I can get them to pay attention for 5, 6, 7, maybe 10 minutes. But then I have to switch to an activity or we have to take a break. And again, it depends a lot on the activity. So something like reading a dense textbook is a very attention demanding process. It takes up a lot of cognitive effort. Whereas watching a movie, you have a much broader attention span because it's less cognitively effortful. It depends on the individual, it depends on the stimulus. That being said, attention is effortful. It takes cognitive resources. We can't sustain it for very long. You can miss information. So because we are excluding irrelevant stimuli, we can miss information that's happening. So in the example of the monkey video, of course you missed the player in black leaving along with missing the change in the color of the curtain. So selective attention, we are focusing on one stimuli to the exclusion of other stimuli, which means that we can miss other important stimuli. But at the same time, I want to go to this last point here, which is that we're still distractible by automatic attention. And what that means is imagine that you're reading and you're reading your ed psych book really intensely, and your roommate comes running in and says, "Oh my God, there's an emergency." Your selective attention, your exclusive focusing on a stimulus would be broken by your roommate coming in and externally distracting your attention. And so what that means is, and I put it as a benefit, but it's both a benefit and a limitation, is that because it's effortful, because it's hard to sustain, it's very easy to break our selective attention. So I'm really focusing on the book and my roommate drops a pot and it slams really loudly. Well, that draws my attention away. But at the same time, you can think about it from an evolutionary perspective, right? It's really important that if something really big, important, potentially dangerous is happening, that it needs to be able to draw my attention away. And that's the evolutionary adaptiveness of automatic attention. And so now that we've understood how selective attention works more specifically, I want to compare and contrast automatic and selective attention a little bit. And so just as a reminder, automatic attention is something like clapping or a loud noise or the lights flicking that draws our attention or draws our mental resources toward itself. So it's an externally stimulated directing of attention, whereas selective attention is an internally stimulated directing of attention. That's when I decide to pay attention to what I'm reading or to the lecture content or to the monkey video. And so I'm going to ask you to compare and contrast these. And again, I do want to give you maybe 15 seconds to think about one contrast, one difference, and one comparison with your neighbor. Okay, so let's talk about some of these similarities and differences. So when we talk about automatic attention, because it's externally triggered, so when I clap, I have your attention for kind of the 1 second that you look up. But if I don't tell you to do something else or I don't do something else, then your attention is gone, right? It drifts to something else. So we tend to think about automatic attention as much more brief. whereas selective attention is more sustained. So again, kind of in the grand scheme of things, selective attention, being able to really focus on a stimulus for 20 minutes is not that long, but it's much longer than what we are talking about when we talk about automatic attention. So automatic attention, we tend to pay attention just for the duration of that stimulus, whereas selective attention, because it's internally driven, we tend to pay attention for a considerably longer period of time. And actually what I'm going to do is I'm going to stop here because I'm realizing that the way the TAs would put these videos together, we're going to run out of time. And so what I'm going to do is in the next video, I'm going to start with comparing and contrasting selective attention. So before we go, please define automatic and selective attention for your neighbor. And we will pick up right here with video 3.